A silent ECM blower does not prove the motor is bad.
Missing line power, a missing control request, a connector fault, a locked wheel, or a failed motor control assembly can all produce the same 0 RPM symptom.
Diagnosis begins by separating evidence, not ordering a motor.
Before resetting power, capture the demand, stored fault code, time to failure, actual speed behavior, airflow or static pressure, and any recent service change. Sometimes stops is not a diagnosis. A repeatable symptom with operating context is: identify the unit model and exact motor label, then lock the control profile, supply rating, connector map, OEM programming, blower wheel, and air system data. Constant speed, constant torque, constant airflow. Tapped in communicating ECM systems do not share one test sequence. If the motor is running but airflow is weak, the system is noisy, a coil freezes, or limits trip, test the air path before condemning the motor. Inspect filters, coils, blower wheel, registers and dampers, measure total external static pressure and verify the selected mode against the unit documentation. Electrical diagnosis belongs to qualified technicians. Follow the site procedure, notify affected people, shut down normally, isolate every source, apply lockout or tagout, wait the discharge time specified by the product manual, and verify the safe state before disconnecting or inspecting components. Many ECM systems need two things at the same time: the correct power supply and a valid enable, speed tap, analog command, or data request. The exact architecture varies.
If either rail is missing, the motor may remain still even though the other rail is healthy.
Using the unit wiring diagram and rated procedure, trace the source, protective device, grounding, harness, connector, and power at the motor interface.
Do not borrow a voltage expectation from another ECM.
Correct a supply or connection fault before judging the motor.
Confirm that the unit actually requests blower operation.
Then follow the request from thermostat or building control, through the unit board, to the motor interface. Enable lines, speed taps, references, pulse width signals and communication buses require different tools and definitions. With the system made safe, inspect connector seating, pins backing out, heat discoloration, moisture, corrosion, drip loop routing and strain relief.
A damaged pin can remove power, reference, data, or feedback intermittently and mimic an electronic module failure.
Read stored codes and use the OEM flowchart, approved tester, or service mode for that exact system.
Compare commanded and measured response.
Do not improvise jumper combinations or apply an external signal simply because another motor used the same connector shape. Only after supply, command and connectors are proven should the diagnosis move to the control module, motor windings, wheel, shaft and bearings. Some controls are integral and contain no field serviceable parts, others permit only a matched module replacement. Follow the exact manufacturer decision. After repair, verify rotation, every commanded mode, airflow and static pressure, current, sound, temperature trend, and that the fault does not return. For interface matching help, send Longwell the unit model, motor label, connector photos, wiring page, fault code, demand, and static readings.